Hi there. We looked today in class at the rest of the UDU process, 4.5b. Yesterday we focused in on just identifying the U and the DU components. Today we're going to go ahead and finish up the rest of the steps here. Okay, and so I selected 4 problems for us to demonstrate this on. First one is the quantity of x squared minus 9 cubed times 2x dx. And then we're going to start with the same thing we started with yesterday. What's my U and what's my DU? In this particular problem, I'm going to be trying my x squared minus 9 as my U first, because that's the composite function piece. That's the function within another function. That's what's inside the parentheses, if you want to think of it that way. Okay. And if this is my correct U, when I do my DU, I should be able to get rid of the 2x dx, or at least the x dx. The 2 may or may not. Coefficients we can manipulate. Okay, and the derivative of x squared minus 9 is 2x dx. And so sure enough, I can get rid of this 2x dx by substituting in my U. Okay, so now that we've identified our U and our DU, we're going to go ahead and substitute. This 2x dx is going to come out, and I'm going to put du in its spot. This x squared minus 9 is going to come out, and I'm going to put u in its spot. And then that cube, because it was never in either my u nor my du, that cube's going to stay. And now we've got a simpler problem, and we can apply power rule to it. We're going to go ahead and add 1 to the exponent and divide by the new exponent. Okay, and then the final piece of a u/du substitution is that my original problem is in terms of x, and so my answer needs to be in terms of x as well. And so I'm going to take that x squared minus 9, that was my u here, and I'm going to plug that x squared minus 9 back into the u spot. And so this is going to be x squared minus 9 to the 4th over 4 plus c. Okay? So those are the last steps of u/du substitution. Okay, number 18 is the next one. We have the integral of x squared times the square root of x cubed plus 2 dx. Again, I'm going to look for my u du. I see my parentheses here around the x cubed plus 2. And so that's what I'm going to try as my u. And so my du, derivative of x cubed plus 2, is 3x squared dx. And in my problem I have x squared dx, not 3x squared dx, and so I'm just going to divide that 3 over. You can manipulate your coefficients, you can't manipulate your variables. Okay, or I should say you can't mix your variables. You can't bring the x over to the same side as the du. Okay, and so this x squared dx is going to be called 1/3 du. Okay, so our last steps here, we're going to go ahead and substitute in. The x squared dx is going to come out, and 1/3 du is going to go in its place. This x cubed plus 2 is going to come out, and u is going to go in its spot. Okay. And then that square root is going to stay in the problem because this square root was never located anywhere in my u or my du, so it's going to remain in my problem. Okay, so now we have power rule. We're going to go ahead and add 1 to our exponent, divide by our new exponent. And dividing by a fraction, remember we learned this back in 4.1, or I should say reminded ourselves of it back in 4.1. Dividing by a fraction is the same thing as multiplying by its reciprocal. And then again, our last step is to take this x piece and stick it back into the u. And so we're going to have 2/9 x cubed plus 2 to the 3/2 plus c. Slide that up a little bit. There we go. 2/9 quantity of x cubed plus 2 to the 3/2 plus c. Okay, so we have 2 more here demonstrating this process. I picked some trig ones so you can see what that looks like. 46, we have the integral of x sine of x squared dx. Again, I'm going to be looking for my parentheses, and my parentheses in this problem are around that x squared. So I'm going to try x squared as my u. And so my du is going to be 2x dx, which there's no 2 coefficient in that problem, so I'm going to go ahead and divide that 2 over to the other side, which is going to give me all the pieces for my substitution. X squared is going to be called u, and x dx is going to be called 1/2 du. Okay, and so here we go, last steps. Pull out the x and the dx, stick 1/2 du in its spot. The x squared is going to be called u, and that sign, which was never in either my u nor my du, is going to stay in my problem. Okay, and so this is a trig one, and a derivative of sine is negative cosine. And then we're going to take our x squared and stick it back into the u spot. So there's your u du process. Okay, and then one more, one that I think is potentially a little bit more difficult. We have 51, the integral of cosecant squared x over cotangent cubed x dx. This one, there are 2 sets of parentheses, one around the cosecant x, all squared, and one around the cotangent x, all cubed. And so if you can't see it initially, you might just try one and see, does cosecant work, does cotangent work? For me, I mentioned on yesterday's video that I like to look for the derivative on problems like this, see if I can see something that already is a derivative. And cosecant squared x, I know, is a derivative. It's a derivative of cotangent x. And there's a cotangent x. So I'm going to try cotangent x first, just to see if it would work. And the derivative of cotangent is negative cosecant squared x dx. And sure enough, I see all of my pieces. Cotangent x is going to be u. The cosecant squared x is in my du. Slight issue with the negative, although it's an issue easily reconciled. We'll just divide that negative over to the other side, and we've got all of our puzzle pieces. Okay, again, if you didn't see that initially, you might just try. Like I said, it's like working a puzzle where you pick up a piece, you try it in the spot, you see if it works. If it doesn't, you try something else. Right? But we've got our pieces here. Okay, so the cosecant squared x dx is going to be negative du. The cotangent x is going to be u. That cubed was never taken care of, so it's going to stay, and since this was in the denominator, it's going to be negative. So then we're going to add 1 to our exponent, divide by our new exponent, and then substitute back in. Cotangent x back in for your u. And there's your answer.